All right. What we are going to do today. So I turned one of those lights to the one that turns off the lights more so we can see a little better up here. That's good. What we're going to do today is go over this. Please turn towards the board, not toward the person sitting near you. What they want us to do here is they want us to look at this picture, explain what you see and why you think this is true. And guys, with this word explain, you're going to explain it probably incorrectly sometimes. It's okay. I'm doing things a little different this year. I used to start proofs right now. I want to stay away from them, and I want to talk about just explaining, because proofs are, in essence, you make a statement and then you have a postulate or theorem to back it up, right? And all these statements add to get you from point A to point B. So you might have 6 statements proving a certain fact, with a bunch of different things. Well, what we're going to work on here basically is having a statement, one statement at a time, and saying, okay, that's why I think this is true. This is the postulate that makes this true, which is basically little pieces, you could say, of a proof. I'd like to start there. So you're going to have to take a leap. You're going to have to try, and you're going to have to put some effort forth to try and understand or try to just explain what you see. Like right here, plane O and M intersect in line R. Okay, so this is plane O right here, correct? It works better when it's not the computer doing it. This is this is O. This is M. This is line R, is it not? Okay, why do we think O and M intersect at R? Well, to be honest, looking at that, how could we describe that? In the picture, what do you think? O meets R at, is this like an edge? At the edge, or O meets not R, but O meets M, the other plane. Okay, O meets M, right? At the edge, that contains line R. Isn't that what we're looking at? They met at that edge. And it doesn't have to be in that fancy. You could say O and M meet at the edge. That's line R. You see how I'm trying to, it doesn't have to be perfect. You guys could explain, anybody else want to give another example of how you could explain that? Okay, I'll try to say it differently. Well, no, but say it in your own words. Like, I could say, the picture shows O and M meeting where R is, right? Can you say that, where R is? But remember, what you have to do is when you're explaining, you need to be talking about what it says up here. Up here it really doesn't say much about points, but you're going to find on this one we're going to talk about points though. But do you see what we're saying? We're just describing what we see. Yes.
So like whenever you're talking about like describing it in a different way, wouldn't playing O and M share line R?
Yeah. You could say in the picture O and M share where R is, or line R. Yeah, absolutely. So that's what I mean, that's what I'm trying to say. Please look up here. Don't talk to the person behind you. Is that I just want you guys to try. Now, here's the point, the part that needs to be right. When they say to what? Name the postulate that describes that. Well, you're in luck. See, when we do this or things like this in a month from now, we would have had about a chapter and a half of postulates to refer to. But this is our first section with postulates, isn't it? So I bet it's going to have something to do with those 7 postulates or 1 theorem we did today, right? So wouldn't it make sense to pull up that picture? I'm going to scare. I bet you it has something to do with one of these things. What postulate? 2 planes meeting at a line. What does it say? just did. We said those two intersected. So you see what I mean? You just have these ones to look through and you just look at the words and say, hey, which one kind of is talking about what I'm doing? That's not too terrible, is it? Okay. So, back to here. It's postulate, and I want you to do POS 2.7. Want you to just write POS for postulate. I'm not going to make you write out the whole word postulate, but POS, hopefully you'll say postulate at least to yourself. That's not so bad, is it? But it is going to cause, people aren't used to doing that in math. This is kind of like, remember those history assignments where you had to go look back in the chapter and see which one talks about this or that or uses those words? You kind of scan and you look. Aren't we kind of doing the same thing here? Kind of figure out what postulate goes with what we're doing. It's, in essence, kind of the same thing. And it's just we're in math class. We're not supposed to. Well, it's going to be a little like that here. This next one, line P lies in plane N. Okay, line P lies in just one plane. And actually here I didn't do this, but what I would probably do first is find the postulate that supports it, and then use that postulate to help you explain. So what are we talking about here? Postulates do they not talk in a very general way? So think general. We're talking about a what? Okay. So let's look on those postulates and see if we can find something that has to do with a line lying in a. If you go to 2-1, for any 2 points, there's exactly one line. Does that have anything to do with that? For any 3 non-collinear points, there's exactly one plane. Now we're talking about 3 non-collinear points in a plane. 9, 2, 7, 3. Oh, look at this. If 2 points line a plane, then the entire lane contains those points. That contains those points lies. So here, the then is saying the line lies in a what? Oh, I didn't change it over. I guess you guys aren't seeing that. Sorry. This first part, the if right here, but then line lies in a. But what makes that happen though? That's the then. If what? So you think I might want to look at that and see if I can pick 2 points that line that plane? Well, now if we look back at the picture, so we're pretty sure it's postulate 2.5. Would you guys agree with that? Yeah. So why is it postulate 2.5? Well, if 2 points lie on a line, lie in a plane, then that line has to be in the plane, right? Do we have 2 points that by the pictures show lying in the plane N? So we could say since A and E lie in N, then P has to lie in the plane because A and E are on P. I mean, I said that in a long, ugly way. There's all kind, you could say that in a different way. Somebody think of a different way to say that.
Would that actually be lying inside the plane? I thought if it was lying inside the plane, it would have to.
This plane goes on forever and ever, right?
Yeah.
So this plane's, it's actually inside the plane. Does that make sense?
Yeah, but what about N though?
N is the plane.
N. Like, what about N? Is it not?
M is an on line P.
Okay.
And we're not referring to M. We're just referring to this. We're just, Tina, bring that up to me, please. Just set it right there. We'll get it after class. Okay, so you guys see what I'm saying? Now, honestly, if you said, well, the picture shows 2 points on that line also in that plane, that'd be okay. You know what I mean? You don't have to be this perfect mathematical way. I just want you to what? What's the word? Try. Okay? It's okay. You're going to learn so much more if you'll try. Then you go in the back of the book and try to figure out if what you're saying is the same thing they're saying, just in a different way. You're learning something then. Okay? And then that P has to be in N. Yeah. Okay. Now, we look down here. Let's go down to here. Now we're going to talk about some things where determine whether the statement is always, sometimes, or never true. These are other type of problems, and we're going to explain our reasoning. Always talking in absolutes, isn't it? If you're going to say something always happens, what had you better have to back it up, probably? Proof. A fact, which is a postulate, a theorem, a definition. So if you're going to say always, I'm betting this should probably what? Be something almost along the lines of saying a postulate or directly to the postulate. Sometimes it might say things that you know it can happen, but a postulate tells you it doesn't necessarily always happen. Never, it probably almost needs to be the exact opposite of a postulate, doesn't? For it to never. Really, this one and this one should be the harder of the two. Probably easy to say sometimes, isn't it? Now this first one could probably be, with you guys just reading the words, you could be up to interpretation. I don't even know what the book's answer is, but I know what my answer would be. 3 collinear points determine a plane. I want you to look at those theorems and tell me if you see anything like that. 3 collinear points. I want you guys to do it. I'm not going to turn it to it again. Isn't it the same thing as 2.2 kind of, except instead of saying through any 3 non-collinear points, ours says through 3 what? So that's almost an opposite, isn't it? Well, the other part of it, so it's saying 3 collinear points determine a plane. Well, to me, when it says determine A, is that plural? So I'm saying how many planes? 1. That's how I interpret that. Determining means those 3 points would be determining that plane and that plane only. That's not true. That never happens, because the thing is, if they're on the same line, you could have an infinite number of planes intersecting, because planes intersect on a line. So the answer to this is what? Never. Why? Postulate what? 2.2. Or you could say non-collinear, not collinear. Wouldn't that kind of be a way of saying what reason it's wrong? Any questions there? It's not too bad, is it? 2 points A and B determine a line. What do you guys think? Always, sometimes, or never? But what should be the first thing you go and look at right now? Postulates. Do you see a postulate that says almost the exact same thing? 2.3 and 2.1 both kind of deal with that, don't they? Probably the one, yeah, you could really probably use either one of them. I think they're kind of looking for 2.1, because that basically says if you have 2 points, then what? They create a line, don't they? And isn't that what these are saying? So what would you say? Why? Postulate 2.1. And like I said, that's up for debate on 2.3. I think that's probably, I personally think that's a fine explanation as well. And when it's all said and done, you're getting the gist of it, aren't you? 5, a plane contains at least 3 lines. Okay, I've got a plane containing at least 3 lines. So just look for those words. Anybody see a postulate? Yeah, the funny thing is the first 1, 2, 3, 4, 5, 6 letters are exactly the same, aren't they? But then instead of saying non-collinear points, they say lines. Well, here's the deal. This is a pretty general statement with saying at least and all this stuff. Do you think this could happen? That a plane contains at least 3 lines? Yeah, that can happen. Do you think it's always not going to happen or always going to happen? No, but can we say it always happens? No, because it's supposed to be 3 what? Non-collinear. So what would you say? That would be my opinion. And I've done these before. My opinion is different than the book. And I to this day will disagree with them. I don't care what they say. Okay, but that's what's kind of neat about this. There is some, and I hope on something like this, when we do a test on this, you guys come to me, Coach, this problem right here, I'm telling you, I think you could have 2 answers. And if I agree with you, guess what? I'll count either of them right. Okay? Sometimes in postulate what?
2.4.
2.4. Okay? Now, going down to here, G and P are collinear. We're just supposed to use the posit. Hey, stop. G and P are collinear. Why do we know 2 points are collinear? What theorem tells us that, or postulate? Because through any 2 points, there's exactly what?
1.
So that's postulate what?
2.1.
Don't you dare put your stuff up. Don't do it. Points D, H, and P are coplanar. That's the one that says any what? 3 points create a what? Any 3 points determine exactly one plane. So that's postulate 2.2. Okay, guys? When I gave the assignment, I took off 1 through 9. Okay? That's me trying to give you less. But I expect to see everything written out, explained, 10 through 13. Still not just it's a few more than you probably would want to do, but it's with stuff we need to do. I think the ones we're doing the most are these down here. I think these 2 are just saying name the postulate here. And of course, write problems, draw figures, show all steps, and work. When you draw the figure, listen. Does it need to be this itty-bitty little thing? No, nice and big, because it's probably going to be for about 4 or 5 problems. I guess I didn't switch it over, so I probably didn't record just my voice, so I'm zooming out. So at the end, you guys, if you wanted to see what I wrote down again, you can. Have a good day.